Why do heat exchangers get dirty, and above all, how do they get dirty? Today we talk once again about heat exchangers. One of the main problems of heat exchangers is fouling. As we have seen in other videos, when designing a heat exchanger, it is necessary to take into consideration the fouling factor or an oversizing in terms of exchange surface to account for the possible fouling of a heat exchanger. Clearly, it depends a lot on the fluids that pass inside. When we have exchangers that treat clean fluids, the problem of fouling obviously does not arise. So we can size the exchanger very precisely based on the working conditions without taking too much into account what could be fouling and therefore a reduction in the exchange surface. When, on the other hand, the fluids involved in the exchange can be dirty, at this point we must take it into consideration. What causes dirtiness? As I was saying, it depends on the fluids. There are different types of dirt. There is a contamination at the level of encrustation when we have fluids that, so to speak, stick, adhere to the exchange walls, and I would say that this is probably the worst case. Or we have a fouling due to suspended solids circulating inside the exchanger. When dealing with fluids containing suspended solids, we can implement different strategies to avoid contamination. One of the key aspects is filtration. Filters act as a bottleneck in heat exchange by reducing the flow rate of water, leading to pressure losses that require higher pumping pressure. However, they play a vital role in protecting us from contamination, making it crucial to have them in place for ensuring water safety and quality. Clearly, there are suspended particles of solid matter so tiny that even a high-quality filter finds it challenging to prevent their passage. For instance, in cases where water containing high levels of suspended solids, such as sand, dust, and metal shavings, is utilized, one approach to mitigating internal fouling in a plate heat exchanger is to introduce the fluid from the lower section. What happens by doing it from below? It happens that these heavy particles tend to settle on the bottom of the nozzle and therefore not dirty the entire plate. This allows us to extend maintenance times. Clearly, if the dirtiness is due to encrustation, we are talking, for example, about limescale rather than resins or oily products that stick to the walls of the plates. At this point, we can say that the only possible solution is a washing. Washing can be done in different ways. Maybe I've already talked about it, with a cleaning in place rather than disassembling the exchanger. So a more accurate washing with a lance, with a brush, with detergent products. But if you want, it's a topic we can delve into. Good day.